Thanks for coming to our workshop. Kerry Weinberg is going to chat about MCP and A2A frameworks and protocols. Mostly it'll focus on MCP stuff, but I think she's been deep in the weeds on all of this, and this is more of a learning space for us to just learn together. So I encourage you to all to ask basic questions, and we'll go from there. So Kerry, I'll hand it over to you.
Awesome. Thanks everybody for joining. I'm Kerry. I'm the founder and CEO of Phenomenal. We make AI APIs that make it easy for healthcare companies to build AI agents and power AI workflows. Really excited to chat with you all today. It's a privilege to be able to share a bunch of this with you. I don't really think anyone in the community we're all kind of learning how these different frameworks work. And so I think it's a great opportunity for us to all learn together. So I'll talk about what we're going to cover today. Also have an open source repo. So once we get to that point in the chat, I'm going to put the repo link in the chat so you guys can follow along when I show different code for the agents we're going to work through. So what we're going to cover today is a couple concepts. So just setting some frameworks you probably have seen, especially if you're on LinkedIn. So many people talking about MCP, lots of demos about MCP, just an enormous amount of hype, to be honest. And then more emerging in the past few weeks, increasingly hype about A2A, which is Google's agent-to-agent protocol as well. So we're going to cover what are they and why are they being so hyped? And also open to any debates and spicy takes from folks on this call who I know have strong opinions on MCP. So I think it'll be a good discussion there. And then the other part is we're going to actually build, or I'm going to show you how I built an MCP server to interact with clinicaltrials.gov. And we're going to build an agent that can actually, we'll technically do 3 different approaches, utilizing agents as tools as part of a broader orchestration agent, as well as having a dedicated agent that can use multiple tools, all for the objective of being able to support a provider or clinician, rather, finding patients that could be eligible for given trials. On a personal note, I'm very passionate about clinical trials and what the clinicaltrials.gov API offers. My background is in, I built out Amgen's machine learning group, so I have a lot of familiarity in the biopharma space. And because of that, when people have parents or friends or family members that are looking for trials, they'll personally contact me, and I personally help people navigate the ct.gov website. So this is an area that I feel very passionately about, and I'm excited to talk through kind of real-world applications of building agents that can make a difference for patients. Cool. So what is Model Context Protocol, and why are all these LinkedIn influencers talking about it? Fundamentally, if you've built any systems with AI and you want to be able to have it interact with an external API, so let's say you want it to support interacting with an LLM to find you directions via Google Maps, or let's say you want to be able to interact with your Google Calendar via an LLM or any other third-party API. Historically speaking, and when I say historically, I mean literally in the last year or so, the way that you would have to do that is you'd be writing using function calling and tool calling from various AI LLM frameworks. And then you'd then have to write code to be able to support it with whatever your user-facing client is for how your users are interacting with the LLM and those downstream tools. So end of last year, Anthropic released this Model Context Protocol to help establish some semblance of standardization and interoperability for systems that interact with data sources and third-party tools, and essentially clients that enable you to interact with an LLM with a human. So the sort of broad opportunity here is that if I have an MCP server that can define sort of a clean interface between my LLM client and my third-party tools, if I have that as a standard protocol, that makes it so that I can port that server to any client. And so why is that valuable? The valuable angle there is, and this, in my opinion, only applies if there's true MCP client support, is that I can take an MCP server that I made, that I got it to work with Claude Desktop, and I can also make it work with OpenAI Desktop, for example, or Cursor. So the idea there is portability. So I don't have to write custom code to then make my server work with other clients, which opens up a lot more potential. So let's say I am Stripe, for example, they released an MCP server. That means that any tool, like an IDE or something that developer uses that they want to interact with Stripe, they could take their MCP server that Stripe released and put it on Cursor to use it with Cursor, or they could use it with another MCP client IDE. Let me think of like another analogy. Well, we'll talk about it today with this clinical trials example. So I made a clinical trials MCP server, and I was able to run it from Claude Desktop, and I was also able to run it from this Google ADK agent. So it just provides portability, and in principle, it provides an opportunity for broader adoption and like community contributions. So when people are saying, I made an MCP server for this, and I made an MCP server for that, the idea is that then it makes it easier for people to be able to actually use those connections between like an LLM and APIs or other tools more seamlessly. In practice, I think most of the ways that folks are using it in the demos I've seen on LinkedIn is like, look, I got Anthropic to talk with my ex. I'm going to be a little contrarian about that later. I'm not sure that that's the real value prop. It's technically an approach you can take, but there are other approaches you can take to integrate with third-party APIs and LLMs that could, in your use case, be simpler. In my opinion, the real potential of MCP is the interoperability and portability of essentially servers that enable you to hook up your interface with a bunch of data sources to a variety of different clients. So what is agent to agent? So if you think about this context where I have an MCP server that essentially says, this is how I'm going to define when an LLM interacts with me, this is how it should behave with the third-party API. If I think of this entire system as an agent that I want to have interface with someone else, so let's say I make an agent that is using a bunch of different tools under the hood. Maybe it helps someone find directions and then books them an Uber. Let's say I want that agent to be able to interact with other agents. So in most of the situation we've been talking about today, the person, the entity that is interacting with the MCP client would be a human. Like you'd be chatting with Anthropic desktop. You'd be like talking to Claude. But the potential of agent to agent, which is Google's protocol, is where the interface between the agent is another agent. So you can envision, like, I have Uber releases an agent that provides conversational support for helping you get Uber rides. I'm just making stuff up. Then maybe I want to have DoorDash agent communicate with Uber agent to support, like, interacting in a more autonomous manner. A2A is super new, and to be totally candid, this talk and the demo don't cover it in a ton of detail. I think last night I was like, maybe I should try to take this agent I built and deploy it and put it on A2A protocol. I told Paulius this morning, I think what's more interesting is, so A2A is the protocol that defines like how agents would talk to each other. But what I find very interesting is that I'd like to explore with you guys today is more the behavior of when you stack these sub-agents together and how the variability stacks up. So a takeaway I have with building with agents and working with LLMs, so I've been in the machine learning space for over 10 years, but my original background's in biological engineering. I find working with agents and LLM systems so similar to working with biology. Because there's just a significantly high amount of stochasticity in their behavior. And I think a lot of people are getting excited and assume like MCP is going to help make things more deterministic or more reliable. I'm not sure if that's the case in practice. And so I'm really interested to explore with you all a couple different approaches to how we do this clinical trial agent and the difference in the behavior of the agent depending on how we build it, like whether we use different sub-agents or whether we give an agent a bunch of tools. I didn't want to like complicate that by then making an agent exposed via the A2A protocol. To be honest, if you dig into the documentation on A2A, it's mostly about handling like agents being able to communicate to each other on, hey, I can do these things, you're not allowed to do certain things, like setting expectations, almost like an API spec for each of those agents. And as well as some interesting components, because for these agents, they are much higher latency than most applications we think about, because they're needing to do a lot of operations. So then it becomes more into how do we make it so we can like let's say in our DoorDash versus Uber agent, you can handle sort of flows where it'll take a long time for one agent to complete and communicate with the other. All that to say, A2A is an emerging protocol. Adoption, I think, will be very interesting to watch. It seems like all the other agent frameworks are adopting it, which is promising. That means that if you're building an agent using like LangGraph, it should interoperate with agents built on Google. It should interoperate with agents built on OpenAI. So there's promise there. But I think today, like for most people, I think this is pretty new. Any questions so far? Oh, no questions. I see the chat. Okay. There's also been a lot of noise in the internet about like competition between Google and Anthropic, like, oh, is A2A competitive with MCP? And it's interesting, like when you read the docs from Google, they're very clear that they're complementary protocols. In my opinion, you could probably extend MCP and it could do a lot of the same. It could be quite overlapping with A2A, depending on like how the MCP protocol progresses. So we'll see, but the sort of the party line from Google is MCP is for interacting with internal tools and third-party APIs, and A2A is for opaque agentic applications. So the idea being like one org builds an agent, how do we make it so that it can securely and in a standardized interoperable way communicate with an agent from another org? Okay, so let's put it all together. And this beam isn't even totally that ridiculous, because we're kind of doing that in this little demo here. But there's a lot of like really interesting situations here where you can like take an agent. You can technically take an agent and expose it as an MCP tool. So there is a bit of a like recursion situation that happens with building this stuff. Okay, so now we're going to go into a clinical trials agent. I'm going to share the GitHub repo, so if you want to like read along, you can totally do so. And then I'm going to walk through the agent. We're going to run it conversationally, and then let me think what I want to do. I'm going to do a quick demo running it from the ADK web UI to show you what we're going to do, and then I'm going to walk through the code. So I think I'm going to kind of like go back and forth. Okay, but before we do that, I do want to show kind of like, I want to talk through like, why is this important? Like, why are we even doing this? And then I'm going to talk through the architecture, and then we're going to go run our little agent, and then we're going to go back and forth and look at the architecture, different approaches to take. So the big problem here is it's actually really difficult for patients to find trials and for trial sponsors to find patients. This is a very non-trivial matching problem. Biopharma spends a ton of money to find patients. Like they will take out billboard ads. They will take out ads all over. I mean, I live in Boston. They take out ads everywhere, recruiting patients. And then on the other hand, you have patients who cannot find trials that they're eligible for. Part of the reason is the clinicaltrials.gov website is actually quite difficult for people to use. It is not designed for a consumer. It's designed for researchers. That's my opinion. And so it contains a lot of terminology and a lot of filtering that you really don't understand unless, unfortunately, you're very familiar with looking for trials or you've worked in the clinical trial space. And so not only are you trying to find trials that you're eligible for, that are currently recruiting and that are nearby to you, and that can be very difficult for people to understand. And so what we're going to do is we're going to use these frameworks. Technically, we're not using A2A. I should have modified that, but we'll be using MCP and Google's Agent Development Kit to build a clinical trial searching agent and have it. We're actually going to integrate it with another agent that I built a couple weeks ago for this out-of-pocket health hackathon that folks used that to build agents that integrated with Campus Medical and MedPlum. So we'll be showing kind of like how we could find a patient chart from the EHR and then be able to find trials that that patient is eligible for. Okay, so the first part I'm going to cover when I go through it is we need to be able to interact. The third-party API we're going to build, work with is the clinicaltrials.gov API. So if you go to like literally clinicaltrials.gov, that's what the search interface looks like. And they also have an API. It's pretty good. I've used it quite extensively actually in the past year. They didn't have this historically. It was actually very, very difficult to get programmatic access to clinical trials data. So it's big props to the ct.gov folks because now they have a really solid API. And so that's what we're going to actually use to be able to have our agent communicate with the ct.gov API and search for trials that our patient might be eligible for. Okay, so I'm going to show you, let's see, which way do I want to do this? Okay, we're just gonna use the trial agent for a second, just so you can see that part. And then I'm going to kind of bring it all together with finding the patient from the EHR and then looking for eligible trials. So let's say I'm looking for trials that a 45-year-old woman with an SCLC in New York would be eligible for. Okay, so I'm going to explain to you what we just did. So one of our agents is a clinical trials agent, and the tools it uses are search clinical trials and get trial URL. So search clinical trials is the first tool that takes the language that I'm describing and constructs a clinicaltrials.gov API call to retrieve the trials that that person might be eligible for. So it detects the different eligibility criteria like age, sex, location, and conditions to then be able to construct a ct.gov API call and then retrieve back the NCT IDs, the National Cancer Trial, National Clinical Trial IDs that are meeting that condition. And so we found a bunch of trials for 45. Non-small cell lung cancer is like a very hot area that biopharmas are investing in. So that's why I chose that one, because I know that there's a lot of trials for it. And so we found a bunch of trials that are currently recruiting, and we got the links back from them. And so now we can take a look and we can see, Sotarsiv is actually an Amgen drug. So that's why I know this one. We can see a bunch of trials that are currently recruiting that our patient, based on the description we provided, might be eligible for, that are actually all in New York, which is where we said our patient was. Okay. So that's one of our agents, which is using the search clinical trials and get trial URL. So now I'm going to show this flow where I get a patient from our EHR. I'm using MedPlum. I get the patient's chart. I figure out what conditions they have, and then I'm going to find eligible trials. And then I'm going to go into the code and show you how it all works. So this was the first part, which is showing you kind of how the clinical trials search works. Now I'm going to actually get a patient from the EHR. This is all fake data. The EHR piece is all fake. The clinical trial part is real. So those are real trials that someone could be eligible for.
And
Paulius, so you took yourself
do you want to pull up MedPlum too, just to show what we're going to see in the UI? Because I think most people are pretty technical here, but not everyone. So this will help.
Oh, okay. Wait, actually, oh no, I don't have the nicer chart view. We're looking at my admin view. Okay, that's my bad. So this is our patient, Mark Scout. If you've watched the show Severance, he's the main character. And I have given him a couple conditions. He has treatment-resistant depression, and he also has dissociative identity disorder. We are not looking at a proper chart view. That's my bad. I don't have that view set up. I'm just showing the admin portal for MedPlum. But the point there is, like, we have preloaded my EHR with a bunch of fake patients. And so we're, figuring out what's going on from our EHR. So I'm going to say I'm looking for patient Mark Scout. And so we're using, what are his conditions? So I'm using Phenomenal's Lengthfire APIs to be able to conduct these searches. So Lengthfire, we support both search and create, and essentially takes unstructured text as well as images, documents, and converts them to Fire resources, and also takes unstructured text and converts them to Fire searches. And so you can use that to power AI native EMRs, you can use that to power different workflows, and you can also use that to power agents, which is what I'm doing here. So Mark has two conditions. So he has dissociative identity disorder and treatment-resistant depression. Can we find trials he could be eligible for his treatment-resistant depression? Oh, sorry. Oh, yeah. And you tell me more. Have the NCT IDs.
Yeah, so I would just say, like, it sounds like it really just kind of mimics just similarly how we chat with like the existing like consumer facing tools, like with the same glitches sometimes. Yeah.
Yeah, it's like you already know this. Like, go get the freaking trial ID. You have it. Oh, you're right. I did have it. And so I found us a bunch of treatment-resistant depression trials. And I'll show you how you could like adjust the prompt or different approaches to building these agents to change up the behavior. And we'll also experiment with how the agents behave differently when we architect our agents differently. So, okay, so I just showed you kind of what, like the what of what we can achieve with these agents and tools. I'm going to then go into the code and actually show you like what does what, and you also have the repo, so you can take a look as well. And it's fully open source, so if you want to fork it, go for it. I mean, it's pretty quick and dirty, so there's probably a lot of optimizations to be made, but just wanted to kind of share like a reference implementation of how you could do so. So, and to be candid, actually, this was my first MCP server I've built. I've been dying to build an MCP server for clinicaltrials.gov. Candidly, I really haven't seen a real need to build MCP servers because I personally think using tool calling with most of the LLM frameworks is very useful. And I haven't felt a real need to add an additional dependency. I think as there's more MCP clients, that'll change, but just wanted to share that. So actually, let me go here. I'm going to show the kind of overall architecture, and then we're going to go through this piece by piece. So I actually took two different approaches, which I'm going to show you, and we can like mix them up and try them out together. The first approach is I constructed I would call them sub agents, but I actually didn't treat them as sub agents. But I have two agents. One agent's job is to grab information from the EHR, do EHR stuff. And it's using Phenomenal Lengthfire APIs to facilitate that. Kind of almost as a pseudo MCP server, if I really think about it. And then we have our clinical trial searching agent, and that's another agent that is leveraging our ct.gov MCP server to be able to look for trials that the patient might be eligible for. So this is the first architecture I'm going to show you. The other architecture I used actually is where I removed this middle layer here, this abstraction, and I just gave this agent multiple tools. So I'll show you the difference in the behavior, but it's interesting to see, like, you can architect this stuff differently. So for example, maybe you don't want to add an EHR searching agent. Maybe you want to give your agent like access to all the tools that are available. There's differences in how the agents navigate when they make mistakes, in my experience. And so I want to kind of share with you guys that difference in the architectural change. If you're a software engineer, you might think, well, you would want like clear separation of concerns. And there's a lot of like engineering architectural choices you typically would make where you would say, well, if I have a bunch of my code that does EHR searching, I should keep it separate from my code that does clinical trial searching because of modularity, a variety of reasons. But what I personally am seeing with these agents, and I'm curious if others are as well, sometimes they do better when you don't like micromanage them as much and you give them access to all of the tools they need and they can independently figure out which tool to use versus needing to traverse it as an explicit tree. I don't know if that makes sense for everybody, but I'm going to go into the code and kind of show you like what that looks like practically. But I find that very interesting. Yeah, I call it like micromanaging agents versus like the AI takes the wheel approach. And in my experience, with this sort of like agentic, where you want it to be conversational, it seems like it recovers better when you just give it access to a bunch of tools versus creating these like clear separation of concerns kind of approach. It really goes against traditional engineering perspective, so it's kind of weird. But yeah, that's just what I've observed empirically. Okay, so I'm going to now show the code to show you kind of the different approaches. And yeah, if you have the repo, you can take a look. This is a more technical audience than our last workshop, so I've just like gone straight into the technical details, but obviously if it's too detailed, like please let me know. So in our code, we have two sections. We have our MCP server, and then we have our Langtifier agent. So I used Google's agent development kit to build these agents. I'm a big fan. I think it's really useful. I think there's a lot of really nice aspects of Google's agent development kit. Interestingly, Google's agent development kit does not by default expose the agents you deploy with the A2A protocol. You have to do that on top, which I found pretty interesting. So that's why this agent that we're building today, actually, I didn't fully expose it as to be conformant to the A2A protocol. Okay, so in our MCP folder, we have our MCP server for clinicaltrials.gov. The cool part is that you can actually take this server, and I like ran it in Claude. So that was pretty neat to be able to just like very easily port it. And then I'm also using it in my agent using Agent Development Kit. And the way that I do that is you can use an MCP tool set is the way that you do that with Agent Development Kit. So first we're saying like create an MCP tool set for my MCP server. So let's say you downloaded the Google Maps MCP server and you downloaded like the Stripe MCP server and you downloaded other people's MCP servers. You would have different tool sets for all of those servers that you want to include, and you could down select which tools that you want. So that would be like the practical approach to be able to take, like, let's say you find some MCP servers on the internet that you think are cool. That would be how you would incorporate it into a Google agent here. I had too much fun last night and I started abstracting this a little bit to make it like more configurable just for myself so some of this is a bit abstracted. Like I build the prompt and I'm like providing a configuration to construct the agent. So just wanted to provide that context there. So this first agent that I'm defining, basically I say like, if you're going to use MCP, this is your tools. If you're not going to use MCP, I'm just giving it tools that I made using Google's normal agent development kit. And so we can flip that flag to see the difference in the behavior. It's actually like literally the same code. So in the MCP server, it takes, the input is a bunch of search fields that the LLM is constructing, and then we make a call to ct.gov. We're doing the exact same thing in our tool calls with Google ADK. So it's like literally the same code. The only difference is that with the MCP server approach, we could technically take that server and port it to like Claude desktop or another MCP client. Whereas this one I made in using Google ADK, I could not do that easily. So that's the value prop, I think, of like MCP servers is interoperability if you have other MCP clients that you're working with. But like the reality is until very recently, there was only two major MCP clients that people were using, Cursor and Claude Desktop. And I don't know about you, but I don't know how many I don't know how many companies want to make their whole UI dependent on Claude Desktop or Cursor. That seems like a very risky proposition for a startup or a company in general to be like, here, I'll just give up my whole user experience to Anthropic. Same thing with Cursor. But I think folks are really excited about using Cursor with MCP servers because you can add I haven't looked at GCP's MCP server, but I've heard folks say good stuff about other Supabase's MCP server with Cursor. So it can be kind of nice with developer tools. And so, yeah, that's sort of my thought there. Okay, so my point was essentially we basically have the exact same code from our MCP server for clinicaltrials.gov and our tools that we're making in Agent Development Kit. The other tools I have are using Lang2Fire, so you can take a look there. We're also building that out as more of a configurable API. We've had a significant amount of interest in the past few weeks with using our APIs to build agents more effectively. So that's an area we're investing in, building a Pheno agent API that makes it easier for you to just call via API and not doing this me hacking it together in Python. We want to offer it as a real API service. So okay, so the first, this create agent here, as I said, you can choose to use MCP or not. It's going to give us an agent. This agent has a set of instructions. I built a prompt builder where it basically constructs the prompt based on a JSON. The reason I did this is because I was mix and matching how I wanted to architect my agent. So in this first approach, I'm giving the agent a mega prompt. It's giving it all of these different capabilities and all of these different workflows in the prompt, and I'm giving it a bunch of tools. So that's the one, that's the first example. In the other two examples, I'm actually creating cleaner separation of concerns. So I'm saying your job is just the FHIR stuff and your job is just the clinical trial stuff. And so it just made it easier for me to be able to kind of mix and match that. So, yeah, so we have create agent. This is basically our AI takes the wheel approach with a mega prompt that I personally actually see better behavior with. But I haven't done a full rigorous study to evaluate. Then we have our specialized agents. So this agent, so in the above example, we gave it all access to all the tools. In this example, we're saying, well, we're going to have a specific agent and its job is only dealing with FHIR stuff using our Lang2Fire tools. And then we're going to have another agent and its job is only looking for clinical trials. And that's the only thing it's supposed to do. And then we're going to actually incorporate both of those agents as tools, which enables this composed root agent to be able to be kind of an orchestrator. So it's going to go, okay, I'm going to actually I detected I need to use the FHIR agent. Let me have the FHIR agent look for FHIR stuff. Okay, I detected I need to look for clinical trials. Let me have the clinical trials agent look for stuff. So those are the different sort of architectural approaches that I've used in this example. So the first one that we just have been running that I showed you, that was my it's using MCP, and I gave it access to all of the tools, and I gave it the mega prompt. So it's not it's not modular. It's a bag of tools and a giant prompt essentially. So that was the one that we just ran when I tested it. So now we're going to use MCP equals false. Okay, so now we gotta. Okay. So now we're going to do the same exact flow.
Gary, if you switch to the browser, we can see the.
Oh shit. Oh no, I was just going off on my own and you had no idea. Okay. Did you see the browser now?
Yeah.
Okay, cool. Sorry, guys. Oh, shit, I should have defined. Okay. Oh, good job. It looked for both dissociative identity disorder and treatment-resistant depression. Can I hit the Toronto trials? Oh, okay. Okay, so this is, and I didn't do the most scientifically accurate case control comparison in this comparison of the different architectures, because I need to set temperature equal to low value to ensure higher reliability and consistency. So some of this difference in the performance likely has nothing to do with the fact that I'm using the MCP server equals false approach, and could be just more related to inherent variability. So just the inner scientist in me is just calling out that caveat. But I just wanted to kind of like show the differences. So yeah, so that's that flow. That was basically all of the tools, giant prompt. I call it AI takes the wheel. Okay, so now we're going to go to here, and we're going to use our, like, I call it, I need a better name, not micromanaging agent, but it's a more composed agent, I guess. Okay. So you see how before it was calling the tool, and in this case, it's actually calling the agent, and then that agent is calling the tool. So we're getting like a level of abstraction. Let's see if it handles the situation.
And Kerry, from while this is running from like the resource perspective, it sounds like this agent approach would be more resource intensive, right?
Latency is a non-trivial concern potentially, because you're adding in that additional call, like you're adding in the additional call to an agent, which then is provided a prompt that it then has to interpret which tools to call. So you may experience higher latency. You also may experience higher variability because you're introducing sort of a more stochastic like interface when you call an agent versus just exposing it directly to the tools. I mean, it did fine, but like, yeah, I thought it would be worthwhile to kind of share the different approaches. Okay, so now we're going to do the last version, which is, I think I do, well, it's my last version is using MCP equals false. Okay. And so let's try it again. Okay.
You may want to flip the screen you're sharing.
Oh, sorry. Thank you.
I feel like there needs to be like the chatbot arena equivalent for MCP versus the ADK approach.
What?
You know how the chatbot arena gets you to compare outputs in parallel?
Oh, yeah.
Because, this makes me wonder if, I don't know, we've not talked about this earlier, but whenever we build evaluations and testing of the performance, how does that really differ, if at all, for which approach you take?
Yeah, I mean, this wasn't the most scientifically valid comparator. Like I would do a much more thorough setup to fully evaluate the difference, and you'd want to evaluate it. But like I just think it's quite interesting. Yeah, so they all work, right? They all accomplish their objective. They're very different approaches to architect them. I think you will create some latency stack up if you're using like this agents as sub-agents and, agents as tools and layering that on. You might increase variability. I haven't fully tested it. There's maybe value where you're encapsulating it more as like a reusable MCP server or more reusable agent that you want to use in other systems. So there could be benefits with reusability. I'm just like, I guess where I always come through is the real point of doing all of this is not technology for technology's sake. It's to make a difference. So whichever approach really achieves the best goal for your end user, whether that's a patient or clinician, like that should be what's motivating us, especially in healthcare. Reusability is really important. But I think like we're still learning how all these systems work. And so I think I'm just kind of curious to see how things shake up. I also wanted to show something. Oh, I see there was like a comment or a question maybe.
I can surface them.
Oh, okay.
It seems relevant. Yeah.
Okay. So I wanted to highlight something. I have a hot take on MCP that I would love to hear if anyone has differing thoughts. Okay. So in this example, and this is not specific to MCP, this is generally about LLMs making calls to external APIs or external sources. The reason why I'm picking on MCP is the point of MCP is interoperability and reusability, right? And so in theory, when I build this clinical trial MCP server and I have open sourced it, so you can go and use it, you could go put it in your cloud desktop or you can go put it in whatever you want, but will you truly reuse it? And the reason why I bring this up is there's tons and tons of these MCP servers coming that people are open sourcing. So there's like Stripe's MCP server, and there's Google Maps MCP server, and there's Todoist MCP server. But if you'll take a look here, I'm defining as the developer exactly how I expect the LLM to receive information and make an API call. And so I'm like a priori deciding, okay, I want it to take the condition, location, intervention, whether it's recruiting or not yet recruiting, age, and I like this API is paginated. So like how many results do you want to get back and so forth. But like, depending on your use case, you might want to restrict this, or might want it to be different, or maybe you want it to process it differently. So in this case, I'm like constructing the query and then I'm just returning back a bunch of NCT IDs. Maybe I want to return back the inclusion exclusion criteria. And so, which would be very helpful because maybe I have my AI to actually evaluate, is this patient truly going to be a good fit for this trial or not? The MCP server developer is the one who's controlling that. And so you just have to be mindful of that. If you're then porting it into your system, what assumptions is that developer making in terms of how they expect LLMs to interact with their tool? Because like I am making an assumption as I build this clinical trials one that like, because I've searched on ct.gov, I know exactly which ones I would do, but you might not want to use my approach. And so you might end up changing this yourself, in which case it kind of defeats the point of the interoperability. And so that's why MCP servers are not as much like an API, like an API spec, I think, as folks may think, or maybe that's just how the community is implementing them. But I guess in practice, like at this hackathon a couple weeks ago, I was like, cool, I want to integrate with Todoist. I'm just going to use the Todoist MCP server. And then I start looking at it, and I'm like, well, I don't know, like I want it to be more restrictive. I only wanted to grab it from this project. Maybe it's faster if I just build like a couple tool calls for my use case. And so I don't know, maybe this is kind of a call to action for the MCP server developers. I feel conflicted. Like, I guess my take is it was so easy and interoperable for me to take this MCP server and show how it works in different clients. Like, that was really cool. But then at the same time, when I've tried to be consumer of other people's MCP servers, I'm like, I'll just do it myself. So I'm just kind of curious on what other people think.
And also, I think it's because, some people are pure builders and others are more stacking on top of what builders create, right? So I think there's just going to be different users wanting different things. Because
Yeah.
just overall, we're seeing a trend where more non-technical people are entering this domain and they just can't build things as easily. So I think you kind of have both truths at once, if that makes sense. I know we had a question more of a comment from Jessica about measuring performance and accuracy. I don't know if you have any more to add to that of how, if you're seeing anyone else doing that already, especially on the accuracy side, because I think that'd be interesting to test out.
I think I haven't dug into ADK's eval support, but I've heard anecdotally it's really strong. So there's a lot of different approaches to do evals. Evals are getting really popular. Some of them are more deterministic, like did it make a valid API call? Did it retrieve information I expected? Some of them are going to be more nuanced and more about like, is it giving back my response in a way that a human evaluator would think would be sufficient? Is it explaining it in easy language that a patient could understand? Like those are other kind of approaches you could take to evaluate. It may not, the concept of performance can be actually kind of subjective in some of these cases. So Bjorn had a question, which is, isn't the point of this to allow people to develop software to use LLMs without having to set up a server that uses them over API? So the real incentive of using MCP servers and a lot of these other tool calls is that you're able to have an LLM interact with an API, but your API, like, for example, like we'll go to the ct.gov website, clinical trials. It's quite like you can call a lot of stuff. It's not that restrictive. Like there's a ton of different querying fields. So some APIs are pretty straightforward. Like if for Todoist, for example, it's like, what's my project ID? What to-do list items do I have? Are they due tomorrow? But some of these APIs, especially in healthcare, like ct.gov, the PubMed API, if you're getting mesh terms, if you're working with EHRs, if you're working with FHIR, they're much more complex and they have much more subject to interpretation from like language to an API call. So I think that's like a non-trivial part of it is that you're trying to get your LLM system to take what a human is saying and convert it to an API call. Obviously, there's more to it for MCP, but that's like a big part of it. Oh, thank you. Oh, Misha.
Yeah. Misha, why don't you share what you wrote? I think it's good to add some context as well, if you can talk.
Yeah, I can talk. So I'm just going to stay off camera because I need to stay off camera this morning. Think of it this way. What's an MCP server? It's just an abstraction layer on top of another API, right? So it's a way of going, hey, LLM, normally you can't talk to this thing over there. So how does an LLM know it can talk to the API that Kerry is currently showing? Well, it can't, right? Because not only wasn't it trained, but it doesn't have tools built into it. So the MCP server tells an LLM, hey, if you talk to me in this specific way, then I will let you access this API over there. Think of it as like a translation service, right? Like you don't speak a language, you're going to hire a translator. That's how you get around it. That's an MCP. Very rudimentary, very simplistic, but like that's the idea. So keeping that visual in mind, when you're setting up this translation layer, you have usually, not always, but you have two levers you can pull. One is when you configure that MCP server for an API, you can say, hey, you allow 5 things. Like I can read something, I can write, let's use some specific examples. So imagine in this case, we're not just searching for trials, but the MCP server allows us to create a trial. So I can enable getting details of a trial, and I can disable creating a trial for my MCP server. Now, the catch there is we're trusting the LLM and the MCP server to like that disable actually is enforced and works. For the most part, it's fine, but just like if you want to be extra careful, depending on your data and compliance controls, and if I put on my compliance officer, security officer had, then like we get into a really weird conversation. But that's one layer of control you have. The second layer of control, when that MCP is configured to talk to that other to the API client, it needs to have some kind of authorization for it. So that authorization, think password, right? So like with my login. But I'm sure a lot of you have used different systems. When you set up that user, that login, you can tell what that user login is allowed or not allowed to do. So if I not only disable the create functionality of that MCP server, but then I don't allow that user that the MCP server is configured with to create, then I have two levels of control that then helps guarantee safety in terms of what an MCP server can and can't do. So that's one of the ways, like, you can introduce kind of a halfway point of like, hey, I want it, like the Todoist example. I want you to like only have access to this one thing, and I want you to be able to do like at least one or two things. And I want to be doubly sure that you don't touch anything else. So you can use something to like quickly put it together if you feel comfortable. Like you have the skills, the background, the confidence to just like, fine, I'll whip out some code. It does the thing that I need. I move on. I don't have to sit here and spend a bunch of time figuring out somebody else's system that's more complex. Or if you're not there and you're like, I just want to use this thing. Like, I don't want to figure out the code. Like, it's easy enough. Another tool you may have, not all of them provide this, but you may have, is just turn off some switches and you're good to go. Hopefully that makes sense.
That was fantastic. Thank you, Misha. That was super
Yeah,
helpful.
great. Thanks.
Sure thing.
Actually, I want to share, and we can also share it after, Paulius, but I think there's a article you recently shared, Misha, in the XPC Slack about some of the security implications of MCP that folks are finding. But I'll find it. There's a couple good takes that you've been sharing in that Slack that I think could be really helpful for other folks. But I do think MCP, to Misha's point, like, I think it's really, for me, I'm quite comfortable with working with these third-party APIs with LLMs. Sorry, I just saw his chat about MCP and security. I'm comfortable making these third-party API calls. It's actually in many cases faster for me to just do it myself than to use somebody else's server, especially when I have to have the extra cognitive overhead of being like, what does my application that I have, do I want to allow or not allow from their thing, or how do I want to change it because it's not exactly meeting my needs. But if you're if you're like new to it, it can sometimes be easier to just use somebody else's stuff. But you just have to really be mindful of the security, the scopes, like how you want the different aspects of that server to be used in your specific application.
Perfect. I think this is a great place for us to conclude. And yeah, I would say, Kerry, you did a really good job. Thanks so much for just digging deep into what you know and sharing that with us, kind of like hot off the knowledge press. Because I know the stuff that you're teaching you're learning very quickly also. I think you really, pulled it all together. So huge thanks to you. And then really appreciate you guys coming as well. We'll share this recording if you want to revisit. And, to be continued, and we'll see you out there. Have a nice day.
Bye.
Bye, Kerry. Thank you.
Thank you.
Thanks, Kerry.
Thanks all. Bye.
Thank you.